Welcome back everyone, and today we're going to turn aspirin into this insane weight loss drug, 2,4-dinitrophenol. This compound goes by the more common name DNP, and sometimes you can find this in supplements marketed towards weight loss, even though it's in a very heavy legal gray area, and some countries have straight up outright banned it. And they were starting to ban this stuff in the 1930s. Okay, if they were banning things in the 1930s, you know it's bad, okay? They had lead in paint. They had lead in gas. Leaded paint was not banned until the 1970s. So if this stuff was banned in the 1930s, it's pretty bad. And now the reason why it's so dangerous is just because it is so effective at doing its job. And this stuff right here causes dose-dependent mitochondrial uncoupling. That's a lot of fancy words, but in essence what this does is this causes ATP to turn into just heat. So ATP is what your body uses as energy. And well, this pretty much causes that ATP to become super inefficient, and it mostly just gets wasted into heat. The best analogy I can give to this is take your car and drop its efficiency down, right? Hitch a trailer onto it. You're going to be consuming a lot more fuel for the same mileage. And this is what this exactly does. So your body has a base metabolic rate, which consumes calories. So what happens is this makes that process super inefficient. And when that is super inefficient, your body starts burning a lot more energy to compensate. So it's just like your car burning more gas to compensate for the weight it's carrying. And that's what this stuff does. But what makes it so dangerous is that your body is burning so much energy and producing so much heat, you can die from hyperthermia. You will overheat and die. But it's really good at causing weight loss because you are burning a lot of calories as your body is trying to keep up with just its base metabolic rate. It's like exercising without doing the exercise. But perhaps a more efficient and better weight loss drug is just to have you consume less calories in the first place. So some kind of drug that would lower your hunger levels. Oh yeah, did I also tell you that this stuff is explosive too? It is 2,4-dinitrophenol. It's a pretty good nitrated compound, and in and of itself, it is technically classified as an explosive. So yeah, there's that too. Anyway, without further ado, let's go ahead and get into the synthesis and make some of this from aspirin. To make our extreme weight loss drug from aspirin, well first we're going to need aspirin. And here I have a lot of aspirin. This is 325 milligram tablets, and there's 500 in each of these bottles. Together, this is 325 grams of aspirin, which comes out to about 3/4 of a pound, roughly. So this is quite a bit of aspirin. But this isn't just fully aspirin. In these bottles here are inactive ingredients, contains cornstarch, hypomellulose, what, I have no clue what that is, some kind of binder I'm gonna guess. Polyethylene glycol and propylene glycol. So most of these are going to be binders, is what I'm guessing most of that is. But for our synthesis, we don't want all these other binding agents, we just want the aspirin. So we can dissolve the aspirin out using a solvent such as 91% isopropyl alcohol. So most of this stuff should not dissolve in the isopropyl alcohol. Propylene glycol will be soluble in our alcohol, but the way we'll crystallize it, it's not a big deal. For our synthesis, we get to do the most satisfying part here. That's to open the bottles, puncture the seals, take out this piece of cotton, which just keeps it from shaking around inside there. And let's go ahead and add this all to our beaker here. Let's add another round in here. That right there is just an insane amount of aspirin. That is insane, but it is so satisfying. Well, I wish I could just eat them because they just... Oh, that's some ASMR right there. Okay, now that we got the ASMR out of the way, let's go ahead and add a bunch of our 91% isopropyl alcohol. And this should start dissolving out all of our aspirin. Probably gonna need more than that, but for now, let's go ahead and turn on strong heating and get that dissolving up. Okay, so it's pretty much reached its point of saturation. As you can see, I can tell you that everything's not fully dissolved, well, all the aspirin's not fully dissolved, because we still have quite a bit of stuff at the bottom. And it's a little bit more stuff than we should have. So I'm gonna go ahead and do a vacuum filtration, and then we'll dissolve up the residuals even more. But you can see our aspirin already caking on our fork here as it cools off. You may be able to see I have been struggling, mainly because this is precipitating in the funnel because the funnel is too cool, right? So that precipitates in there and clogs it. So I've moved it to 1,000 milliliter, added more solvent to hopefully dissolve all of it. Anyway, I'm going to refilter this and heat this with a blowtorch, like preheat it, so hopefully that'll work. This is insanity. Reheating my funnel here. This took way longer than expected. I cleaned up the mess, but it's always the simple things that go the longest. I'm like, hey, this is so simple. A simple solvent extraction. This is going to take 5 minutes. And then just a disaster. A true disaster. Anyway, so here you can see it's already starting to crystallize out. This is our pure aspirin. Look at that. But we need to get rid of all this excess solvent in here. So the best way to do that is just to boil it off. Since it's isopropanol, it's safe to boil off, and it's so cheap that there's just no point even trying to recover it. So we're just going to boil it away to get rid of it. What was left in the filter paper, this is all of the binding agents and stuff. It's actually extremely satisfying just to crumble this. Ready? Yeah. All right, we got it boiling down here. You can see it's forming this weird crust. We'll knock that back in. There's definitely still some solvent in there, so we'll keep letting that boil down. Okay, now it's boiled down and got pretty mushy, but to get the rest of the solvent out, I'm going to go ahead and just dump it into this glass dish here. And I'm going to let it dry out on this. And this right here is already crystals of our pure aspirin. Okay, this took way longer than it should have, but here we go. Here's our nice pure aspirin. So let's go ahead and grind it up and powderize it and check our yield. Painted my hot plate. Looks nice, huh? Final yield is 236 grams of aspirin. So as you can see, we're actually almost missing 100 grams. So our yield here is only like 70%, which is really bad for such a simple procedure. But as you saw, I spilled a lot. There was a lot left over in the beakers. Things like that just dropped the yield quite dramatically. If I didn't spill so much of it, it would be a lot better. So some of this is probably salicylic acid because of hydrolysis. And it smells very strongly of vinegar, so there definitely is some hydrolysis going on. And why is that? And that's because our isopropanol was only 91% isopropanol, so there's 9% water in there. And well, when boiling it down, that 9% water leads to the hydrolysis of our aspirin. So I say pure aspirin, but really this is a mixture of salicylic acid, aspirin, and some vinegar. That is no big deal because in the next step, we're going to be converting this to salicylic acid. Okay, now I'm going to add 100 grams of our aspirin here into this 1,000 milliliter beaker. Okay, now I'm going to add about 800 milliliters of water. And then now I'm going to go ahead and move it to this hot plate. And I didn't hit record, but I just added 20 milliliters of 31% hydrochloric acid. We're going to add a stir bar, and we are going to turn on stirring along with strong heating. Okay, it's been about 2 hours now. You can see everything has pretty much kind of dissolved. It is still cloudy, but that's fine. But for the most part, it did dissolve, and the hydrolysis should be complete. So we're going to go ahead here and turn off our stirring and turn off our heating and let it cool down, and our salicylic acid should precipitate. And yeah, right on the brand new paint job, it decided like flash boil, and you can't win. You can't win. Okay, and after running for like 4 hours and cooling down, here's what we are left with. This should be pretty much pure salicylic acid. So let's go ahead and vacuum filtrate this. Okay, here is our yield of salicylic acid. Has a nice fine white powder. It is still a little moist, so I'm going to go ahead and, I hate that word moist, I hate it. But let's go ahead and put it on the hot plate, and we'll put it on a very gentle heat to go ahead and kind of dry that out a little bit. I do have to be very careful here with the heat, because if we heat it up too much, we can start accidentally decarboxylating it to phenol. I stopped drying it because I realized the next step we're going to do, we really don't even need to dry it. So let's go ahead and move on to the next step. And now to this 1,000 milliliter round bottom, I'm going to go ahead and add in all of our salicylic acid. And actually having it dry would probably make this step a lot easier. Okay, I'll be honest, that took way longer than it should have. Jeez. Anyway, we got it all in there. You can definitely see it is still a bit wet. Let's go ahead and turn this into some phenol. And to do that, we are going to set up for a simple distillation. So plop that right on there. Now I'm going to go ahead and throw in this 100 milliliter round bottom flask, and that's just to collect any water that may come its way. And yeah, I'm not going to put any water through this condenser here because our phenol has a melting point of like 43 C, somewhere around there. So if we add water in there, right, it's going to completely solidify in the condenser, and that's going to be not good. Pretty much, we're just going to go ahead over here and turn on strong heating, and this will start heating up our salicylic acid. And we should probably get our water over first. That's why I have this little flask here, but this will start decarboxylating, right, forming CO2 and phenol, and the phenol will then boil over and hopefully collect in our flask right here. Okay, we're starting to get some stuff over here first, and we're at 100 degrees C, so that's just going to be water coming over. Okay, whoa. Okay, from some research, I think this is ferric salicylic. So, yeah, what I found is that when ferric ions, which I'm guessing was what was in there, come in contact with salicylic acid, well, it forms a nice purple compound. I mean, that is a beautiful purple. I'm gonna have to make some of this compound myself. That's a great Halloween purple right there. Oh, it's just so good looking. Figured out where the ferric ions came from. This thing had some hydrochloric acid coming through at one point. I always put it on this. That started dissolving a bit. Some ferric ions then got in here, and then it dripped back into here, producing that beautiful compound. Okay, we've pretty much collected all the water. We actually, that had 50 milliliters of water in it. Let's let this heat up, and we should start producing our phenol here any minute. And as you can see, we are starting to get something over. Look at those crystals. That is beautiful. Just beautiful. This place is a mess. Had one issue where the whatchamacallit, this clogged here, the vacuum takeoff adapter, and this popped up, and there's a massive cloud of phenol vapor. Just good thing that all the fans going, it sucked it right out. But yeah, it kept popping, annoying. Anyway, so we're left with this nice tar here. You can see it is liquid. I don't really know what that is, but it's gonna be a bunch of garbage. And here's what we collected. So there is a white crystalline substance, which is our phenol. And it looks like there's something else we distilled over that's dissolving our phenol, and it looks like we have a water layer on top. So anyway, let's go ahead and redistill this and collect our pure phenol. Okay, we're starting to get stuff over, and it's coming over about 103 Celsius, so this is probably just residual water too. So we'll let that distill off. Yep, now we got something coming over at like 111. I have no clue what that is, but it's not our phenol. Our phenol should come over around 181 Celsius, so still gotta wait a bit more time. Okay, now I swapped out to the final container where we're going to store our phenol. And yeah, now we should be distilling over our phenol here any second, and we'll collect it up. What we collected for the first fraction, I have no clue what this stuff is. Interesting, it's kind of thick and oily. Well, in the end, here's our phenol that has crystallized out into our glass here. And here is some tar solution stuff left over. So yeah, but we got our phenol, and now we can finally move on to the final step of making our weight loss drug. Just admire the crystals of this phenol. Phenol crystallizes just so amazing. Okay, so now we have to nitrate our phenol. And if you can guess by the name, that means we add nitro groups to it, right? So we have 2,4-dinitrophenol. So we need to add 2 nitro groups to our phenol in the 2 and 4 position, as shown right here. And for that, we're gonna have to do a nitration. So here's our nitration setup. And to begin, into our 250 milliliter 3-necked flask down here, I'm gonna go ahead and add around 50 milliliters of azeotropic ethanol, so around 95% ethanol, and we'll stop her off the flask over here. Okay, so into our addition funnel up here, I'm going to add 12.5 milliliters of azeotropic nitric acid into the addition funnel. Okay, now I'm going to take 2.5 grams of our phenol here. Look at those nice crystals, beautiful. And we are going to add it to our flask. I'm going to increase the rate of stirring. Make sure it's stirring nice and fast. And then we'll add our phenol in. Okay, as you can see, our addition is fully done. We do have some nitrogen oxides in there. That's just from the nitric acid. But you can see we only went up about 3 degrees Celsius, so that's good. And now we can go ahead and move on to our next step. Okay, now I'm gonna go ahead and change off this addition funnel. And instead, we're gonna replace it with this condenser. Okay, now we got everything going, and we're gonna go ahead and put it on a reflux. So this will condense our stuff over, and we are just going to give this very gentle heating because this is explosive, right? Okay, now we're starting to reflux. As you can see, it's starting to drip down. We've got this dark red solution. It hasn't really gotten any darker, so that's good. And yeah, now we just gotta let it do this for an hour and a half. This is like an ultra dehydrated piss red. One time I spewed this out myself on like my, I don't know, my birthday party when I was like 13. All I was drinking was soda and playing outside. It literally looked like I had blood in my piss. It looked considerably like this color. That was very concerning. So yeah, drink more water. Water is like good for you or something. Okay, an hour and a half later, the color's actually gotten lighter. So I don't know if that's good, bad. I really do not know. So I'm gonna go ahead and turn off heating now and let this cool down. Okay, so now we are set up for a simple distillation, and pretty much the idea behind this is we distill off all of our solvents, and we'll be leaving behind our 2,4-dinitrophenol. And we're gonna be doing this under vacuum. Why? Because our 2,4-dinitrophenol is explosive. Yes. So we don't want to heat that to dryness because then we run a risk of an explosion. But under the vacuum distillation, the vacuum lowers the temperature at which we can boil things, and therefore we can collect off all the gunk and not, you know, blow ourselves up. So go ahead and turn on the vacuum pump. And then let's turn on heating and let it go. Well, here's what's left after our distillation, but I had a nice little fun time. There's a reason why it's in the water right now. I took it off, and you know, I'm just looking at it just like this. You know, it's cooled down. It was cooled down, so I was just going ahead and looking at it, and then I put the stopper on it, you know, a little bit before while it was still a little warm, and I see the liquid boiling in there. I'm like, oh, maybe it's boiling due to the pressure drop, right? Because once it was hot and it got cold, the pressure would drop, you know, from the vacuum, and then bam, it was causing it to boil. And then a red cloud starts to form inside there. I was like, oh crap, that is clearly from a runaway reaction. So I went ahead and stuffed it in the cold water here to, you know, cool it down fast and try to save it. But it was too late, and this stopper literally shot up, hit the ceiling, and then came back down and landed on the table. And then, yeah, the cloud and nitrogen dioxide got sucked out. But that was a little scary. That's nitrations can be very suspect. But anyway, let's go ahead and do a vacuum filtration. And you can see we do got a yellow crystal in there. That should be our 2,4-DNP. So we'll collect it and then do some purification steps. Okay, so now I'm going to transfer our 2,4-dinitrophenol. Actually, hey, how about I just take this off so I don't have it pouring through, and pour it into this beaker here. Okay, now what I'm going to do is add some water, which it should not be too soluble in. Okay, my phone just ran out of storage. But anyway, we have 50 milliliters of water now with our 2,4-dinitrophenol. So now I'm going to add to this drain cleaner, which is just 100% sodium hydroxide. And since our 2,4-dinitrophenol is fairly acidic, this should convert it into the sodium salt. And the sodium salt should be readily water soluble, and it should pull it into solution. Actually, I'm going to go ahead and up this amount to 100 milliliters. Okay, now I'm going to add it to this hot plate, give it gentle stirring and gentle heating, and try to get all that to dissolve. Okay, so here's our solution now. You can see there's a little bit of undissolved stuff, but for the most part it did dissolve. We're gonna go ahead and vacuum filtrate this to get rid of that undissolved crap, and we should just be left with pretty much a pure solution of our 2,4-dinitrophenol and maybe some other nitrated phenols. Okay, so we were left with a little bit of stuff left behind, but not that much. Down there's our nice dark red solution with all of our sodium salt of our 2,4-dinitrophenol. So let's go ahead and take this apart and move everything to this beaker. Okay, now I'm going to add hydrochloric acid, and we should witness a pretty beautiful precipitation of our 2,4-dinitrophenol acid. Yeah. Oh, looks like adding milk to a coffee. Okay, that should be good. Let's go ahead and give it a pH test, make sure it's acidic. And as you can see, very acidic. So let's go ahead and vacuum filtrate this. Okay, there it is. 2,4-dinitrophenol. So to do our recrystallization, I'm going to take all of our 2,4-dinitrophenol and add it into a beaker. And now I'm going to add 95% ethanol until it just barely dissolves our 2,4-dinitrophenol. Now we need to fully dissolve it, so I'm gonna go ahead and add it to the hot plate and turn on strong heating. I ended up adding up to like about 40 milliliters because what was in there was definitely not going to fully dissolve it. Okay, now it's fully dissolved. Now we can take it off heat and let this cool down, and we should see it starting to crystallize. Now I've placed it in the freezer to let it cool down fully. Okay, here's our solution after sitting in the fridge for a couple hours, and see we got some nice crystals in there. Probably should have used a little bit less ethanol, but this will work. This should be our nice pure 2,4-dinitrophenol. So let's go ahead and do a vacuum filtration. So in the end, here's what we're left with, some nice yellow crystals, and this should be our 2,4-dinitrophenol. Let's go ahead and do one more melting point test just to confirm. Okay, it's all loaded in, all ready to go, and let's find out where this bad boy melts out. And at 108.5 C, it is melted. Yep, just like that. Take it out and give it a look. Beautiful. So this is in fact 2,4-dinitrophenol. So there it is. It's pretty awesome that this was made all the way from aspirin. And no, I will sadly not be taking any of it because, you know, it has a good chance of killing you. Well, that wraps it up for today's video. I hope you guys enjoyed. And there it is, 2,4-dinitrophenol, aka our insane weight loss drug from aspirin.